Hello everyone, welcome to lesson 6-6, simple and compound interest. In this lesson you will solve simple interest problems and apply the simple interest equation to real world problems, and you will solve compound interest problems. Let's take a look at the formula for this lesson. And what is simple interest? Well, interest is the amount of money paid or earned for the use of money by a bank or other financial institution, like WFCU or a credit union. Simple interest is paid only on the initial principal of a savings account or loan. To solve simple interest problems involving an annual interest rate, use the following formula. So when they're talking about simple interest, this is the money that you make on the initial principal. Initial principal is the amount of money that was, for example, if you put $100 in your savings account and you are making 1% simple interest rate, you're going to make 1% on that initial $100. Not on, let's say after a year, you make $1 on that $100. Now you're not making interest on $101, you're still making only interest on $100. That's simple interest. Compound interest means you would be making interest on the new amount that already includes the interest you've made. Annual interest rate. Okay, so let's look here. It looks like interest equals the principal times the rate times time. Okay, so the interest, it means we have to take the principal. The principal is the amount of money invested or borrowed. So invested means the amount of money you've deposited into a savings account, or the bank can also charge you interest if you borrow this money from them, like a credit card. So that's the principal. That's the initial amount of money we are talking about. The rate is the percentage converted into a decimal format or form, so we can actually multiply it. And then time. How much time are we talking? And it's always by year. It's always annual. But sometimes you can have half a year, so you would put 0.5 or different amount of time in the year. Okay, example 1. Find the simple interest rate, round to the nearest cent, if necessary. So we have $1,000. That's our principal. That's the first amount of money. It's at 4.5%. 4.5% is written as, well, we have to divide it by 100, so it would become 0.045. Okay? Barely squeezed that in the screen, sorry. And then time would be for 2 years. So we are going to multiply $1,000, as you can see, times the rate, converted into a decimal, times the time. And that's going to give us $90. So after 2 years of having your $1,000 in an account, in a savings account at 4.5%, you're only going to make $90 on that amount of money. So the simple interest is $90. You can tack that onto that $1,000 and you would have $1,090 after 2 years. Let's try again. $2,500 at 6.75% for 3 years. Again, principal times rate times time. Here's your principal, your initial amount of money, the rate converted into a decimal or expressed as a decimal, and your time. And you would earn $506.25 on your principal. So it would bring it up to $3,006.25. And there it is. Your simple interest rate is that. Now that's just assuming that these amounts of money are what you deposit in your bank account. If you borrow these amounts of money at these rates, that's actually how much money you would owe the bank on top of the money you originally borrowed. So that's why they say invest it or borrow. Let's try the formula interest equals principal times rate times time to solve 1A and 1B. Go ahead, pause the video, try it on your own, and then play. Pause now. Okay, I hope you paused the video and you are ready to check. I wrote down the formula already. Interest equals principal times rate times time. Now I'm going to replace my variables with these values here. And I have 2,250 times 0.06, which is 6% written as a decimal, times 4, right? 6% at 4 years. There it is. We just multiplied all three, and you should get 540. So therefore, it would be $540 after 4 years. That would be the simple interest. Okay, let's check 1B. Interest equals principal times rate times time. 4,000 times 0.0425 times 1. Obviously, you don't have to multiply it times 1 because you're just going to get the product of these two. So if it's ever 1 year, you don't have to multiply it times 1. You can leave that out. But make sure that you do include it if it's 2 years, or if it's more than 1 year, or if it's less than 1 year, because that will change this product. And that equals 170. So $170 on $4,000 at 4.25% for 1 year. Now let's find simple interest in context in a word problem. Mr. Gable borrowed $1,860 to buy a computer. So he borrowed this. Maybe from a credit line, from the bank, a credit card, Visa. He will pay $71.30 per month for 30 months. Find the simple interest rate for his loan. Okay, so we have the time, right? And we have to figure this out, what this is in terms of year, okay? He will pay $71.30 per month, and here's our principal, okay? So we have to figure out how much he's actually paying after, if he's making these payments for 30 months, how much is he actually making? Because then that would be the difference between the original amount he borrowed and what he's paying back. So let's see here. Use the formula interest equals PRT. First, find the amount of interest he will pay. So, like I said, he's paying $71.30 in times 30 months. So he's actually paying $2,139. That's what he's going to finish paying when he actually only borrowed this much. So clearly he's paying more, so there's definitely interest. Let's find the difference between those two values, and it's $279. That's how much he's paying. So the interest is $279. You see? So the principal is $1,860, as we said. That's how much he borrowed. So principal is $1,860. The loan will be for 30 months, or 2.5 years. You see, this is what I was trying to say. You have to turn the time into years. Every 12 months is 1 year. So 12 plus 12 is 24, and 6 is 30. So here you have 1 year, here you have another year, and here you only have half a year. So 2.5 years, right? And that's what you would multiply by. So there it is. Now you have your interest. We already found it. 279 is our interest. 1,860 is our principal. We do not have the rate, but we have the time. So we're solving for just one variable. And we can use property of equality. We can use division property of equality to solve for both sides. So first thing that we want to do is we want to try to isolate the r, right? And what we're going to do is first, let's work with like terms here. So we're going to multiply the 1,860 times 2.5, and we get 4,650. Then we divide both sides by that amount so that we can isolate r by using division property of equality. And here we have. We have a rate of 0.06 as a decimal, which is 6%. Okay, let's look at the word problem together and try to solve it. Suppose Nantai placed 2,400 or 2,400 in the bank for 5 years. He makes $9.20 in interest each month. Find the annual interest rate. Okay, so go ahead, try this on your own. Pause now. Remember to look at the example above if you need help. Okay, let's see what information we are being given. So we have $2,400 in the bank for 5 years. In those 5 years, he makes $9.20 in interest each month. each month. So we have to convert these years to month, and that's 60, right? Because each year has 12 months, so that's 5 times 12 equals 60 months. And in each one of those months, he's making 920. So we have to multiply that by 920. Okay, 2 times 0 is 0, 2 times 6 is 12, 9 times 0 is 0, 9 times 6 is 54. We add it up, and we get 5,000, no, not 5,000, there's decimal has to jump over once, 552. Okay, so now we have enough information to move on. Our interest, we just figured out what it is 552. So let's put that right in there, 552. Our principal is 2,400, right? Our rate, we do not know what our rate is. That's what we're looking for. And our time is 5 years. Okay, so let's work with these two like terms first. And 2,400 times 5 is 12,000. Oh, 12,000. So it's 12,000 R. And on this side I have 552. So I'm going to divide out the 12,000 from both sides to isolate the R and to find my percent. These two cancel each other out, and I am going to get 0.046 when I divide those two numbers, which is 4.6% when you multiply it by 100 or convert it into a percentage. So the answer for this would be a therefore statement, stating therefore the annual interest rate is 4.6%. And finally, we have example 3, and this will be our last part of the lesson, example 3 with the got it question. Now we're going to work with compound interest. This means we add the interest to the principal and we continue to find the new interest to the new principal, because the principal is changing every time we add more interest to it. So what is the total amount of money in an account where $600 is invested at an interest rate of 8.75% compounded annually for 2 years? So that means we're going to make 8.75% on 600 the first year, and then we're going to make on the second year 8.75% on the new principal. This principal will change. It will be the 600 plus the interest from the first year. That's what compounded means. So first step, let's find the simple interest rate, and you can see it right there. Find the amount of money in the account at the end of the first year. There it is. You see, 600 principal, interest rate 1 year. It's $52. We add the 52.50 to the 600, and we get $652.50 after the first year. This is now our new principal for the second year. As you can see here, find the amount of money in the account at the end of the second year. Notice how our principal is now different? That's compounded interest. It keeps getting added to the original principal. We continue to add them out, and this is what you want. You want to make interest on compound interest. And there you go. You have it. 5709 would be the next year. You see how you made a little bit more money the next year? About an extra $5. That's what compound interest is. So the amount in the account after 2 years is $652.50 plus 5709 or $709.59. There we go. Let's try that. So again, you will have 2 steps to do it. Let's read through it, and then I want you to try it on your own. What is the total amount of money in an account where $5,000 is invested at an interest rate of 5% compounded annually after 3 years? So we have to do it 3 times, right? We have to find the interest for the first year, then the interest for the second year, and the interest for the third year, because the principal changes every year. Go ahead, pause the video and try it on your own. Pause now. Okay, so let's I hope you paused. Let's check now for year one. In year one, we start with a principal of $5,000, as you can see right there. So we're going to multiply our $5,000 times 0.05 times 1, because it's only 1 year. We have to do 1 year at a time. And for our first year, we get an interest of $250. That $250 must now be added to our original amount, our original principal. And we get $5,250. That becomes our new principal for year two. So for year two, we have interest equals $5,250 times 0.05 times 1, right? But I'm not going to multiply it times 1 because I'm just going to end up getting the same. Remember, property of identity, right? Multiplication property of identity. So here we go. So our second year, we have $262.50 when we multiply. And now that amount needs to get added to our principal from before. So our new principal becomes $5,512.50. And that's what we're going to use for our third year. Let me make some room here. And let's write down our new amount. Our interest for our third year is our principal, 5,512.5, again, times 0.05. And our interest for that amount is $275.6.25, or we can just say 275.63, right? To get rid of the thousandth of a cent. And we add that to our running total, 5,512.5, plus our new interest, $275.63, and we get $5,788.13. Wow. So how much did we actually make in interest? We started with $5,000. Remember? Look up here, $5,000, and so we made $788.13 in compounded interest after 3 years. That is fantastic. Okay, that's it for today's lesson. Go ahead, complete the guided independent practice, and I'll see you next class.